Here is an example. In this example, we're going to find the current supplied by the source, I equal to how much, by using a series parallel combination method or star delta method. So here we cannot use series parallel combination method because none of the elements are in series or none of the elements are in parallel at this point. What is the condition for series? Series means same current has to pass through them. Parallel means the starting point of two elements must be same and ending point must be the same. Ending point of those two elements must be same. So if you look at this 25 and 10 ohms, yes, they're starting at the same node, but they're ending at different node. For sure, they're not in parallel. And same thing with any other elements there. Okay, so the easiest way, the simple way I can think of is converting a star into a delta or delta into a star. So where do you see delta? I can clearly see these three elements are in delta. That's one thing. Another delta is right there, this 15 15 15 in delta. And when it comes to star, I can see this look like a star. This 25 15 and 15 look like a star. So we can use any methodology. I mean, you can any methodology in the sense either you can transfer a star into delta or delta into star. So I'm going to solve the same circuit in 2-3 ways. First, I'm going to convert the first given delta into a star. Okay, so the important thing I always say, label the resistors. Okay, I'm going to label this as A, B, C. Okay, so this must be RAB, RBC, and RCA. Okay, now once we transfer the circuit, we're going to end up RA right there between those, I mean starting from RA, and RB is right here and RC is right here. Okay, so I'm converting a delta into Y. So if you remember the formulas, I need to find RA equal to multiply these two resistors which are connected to RA, which is RAB times RCA over total resistance, RAB plus RBC plus RCA. So here RAB I have 10 ohm and RAB is 25 and RCA is 10 ohm. 25 and 10 multiplied by 10, the total is 25 plus 10 plus 15. So 250 RA equal to 250 divided by 50, that is 5 ohm. Okay, RA equal to 5 ohm. Same way I'm going to find RB here. RB is 25 multiplied by 15. Okay, RB equal to 25. RB is connected between RAB and RBC. I'm not writing the equation there. So RAB equal to 25 and RBC is 15 divided by RAB plus RBC plus RCA, 25 plus 10 plus 15. This value is 7.5 ohms. Now RC equal to, I have RBC and RCA, so multiply 15 times 10 divided by 25 plus 10 plus 15, which is 50. So 150 over 50, that is 3 ohm. Okay, now I'm going to put these new elements by eliminating the old elements. So I see so many times the biggest mistake I saw in the past, many students are going to draw both RAB as well as RA, which is not true. So here I have RA RB and RC. Okay, that's what we have, RA, RB and RC. Now from there we have two more resistors, and then this whole thing is connected to a source. Okay, so here this is 15 ohm, this is also 15 ohm. We just found this as 3 ohm. What is this value? This has 5 ohm. This is 7.5 ohm. Now after looking at the circuit, after transferring the circuit or transforming the circuit, now look at the circuit. Now this RB and this 15 ohms, they are in series. How do you know they are in series? As long as it's the same current passing through them, they are in series. So whatever current comes here, the same current is going to pass through RB and the top 15 ohms. So definitely they are in series. Same thing here, the RC and these bottom 15 ohms are also in series. So we will end up with the RA, this is 5 ohm, and then this is 22.5 ohm, this is 18 ohm. Okay. Now this whole thing is in parallel with, in series with 45 ohm. Now I can clearly see from this circuit, I can clearly see 22.5 ohm is parallel with 18 ohm. So the parallel combination is 22.5 times 18 divided by 22.5 times plus 18. So that value is 10 ohms. Now I have 5 ohm in series with 10 ohm. So the total current supplied by the source is I equal to V over R total. I have V as 45 volt and R total is 15 ohm. So I equal to in this case 3 ampere. So the 3 ampere current is going to start from the source, okay, and 3 ampere is going to divide there. So if you go back, it's the same thing. Now even in the given circuit, this is 3 ampere. How the current is going to divide from there, if you need to find the current in any, either this resistor, you can find it by applying KVL or KCL, or sometimes we may need to apply both. Now by using star delta, can I find the current there? Yes. If that is the case, you shouldn't transfer this 25 ohms into something else. After transformation, for sure, I can find the current passing through here. The current passing through 50 ohms is whatever the current we're going to, the current it's going to split here. You can use the current division rule. I'm going to find that. So the current division rule is total current, whatever the current entering here at this node, total current multiplied by opposite resistance. So here opposite resistance is nothing but these two resistors are in series. We need to use those two resistors. So the picture here, you can see 3 ampere is entering there. Our goal is finding this I1. So to find I1 equal to total current multiplied by opposite is 18 ohms. This 3 ohms and 15 ohms are in series. So 18 divided by total resistance, which is 18 plus 22.5, which is 40.5. That value, I end up with 1.33 ampere. So if 1.33 ampere is passing through that, the remaining current 1.667 ampere is passing through this, okay, passing through the bottom resistor. Now from there I can tell the current passing through here is 1.33 ampere, current passing through here is 1.66 ampere. Okay, based on this I can use the voltage division rule and find the other parameters. Okay, I'm going to stop this video here. In the next video I'm going to solve another example. Actually, I'm going to solve the same example in a different way. Thank you.